All right. So this one is about the observer effect. And when I first kind of came across this, there's a lot of um, consciousness creates reality stuff that is generated basically from the observer effect and its potential implications. And there's like two sides to this. There's people that say consciousness creates reality, and then there's the side that says that there's nothing magical going on here. It's just because we're observing it with instruments that this happens. And I'm not totally set on my opinion on this yet, because a part of me is a strong believer that consciousness does in fact create reality, on some level. Uh, because your consciousness creates your actions, and your actions creates your reality for you. Because if you wanted, if you wanted to, say, eat a sandwich, your consciousness can make that happen, right? And you can say, oh, well, that's just you doing it. I don't even know how you could argue against that not being the case, that but your consciousness wanting a sandwich makes a sandwich, because it 100% does. Like, if you didn't want the sandwich and you didn't make the sandwich, you wouldn't have the sandwich. I don't know. That's a tangent. Anyway, getting back into what I'm saying here is the observer effect explanation that measuring the particle changes its action, to me, makes no sense. Because a part of me understands what they're saying is basically like, we can't observe the particle and know its position without affecting it, right? We have to shoot it with basically light in order to observe it. And once we do that, we've affected the particle and changed it, right? And I understand this. This makes sense, and I'm not saying that it doesn't. But what I don't understand is, okay, so basically we're saying, right, that light, I think that this is pretty well established, that light takes the most efficient route, right, or the most efficient path possible. It travels every path, but the path we observe, right, is the most efficient path possible. And so, when we observe things at like that, right, we're saying, okay, well, that must have been the most efficient path. So when we're watching this double slit experiment, right, with single particles going through, and they land at different spots, right, and it creates a wave, and we get this wave pattern, right? There's no wave there. There's only a single particle, because it's a probability of where it will end up. And this probability is based off of factors that, we probably aren't even aware of. But, when a particle flies through the air, there are so many things that can affect it that, we wouldn't even see necessarily. So, its trajectory is not 100% certain, because there's just so many possible factors. Anyway, that's another tangent. We're shooting these particles and we're getting this wave pattern. And so, we can assume, okay, well, this one landed here because at that point in time, it was the most effective, or the most efficient route to get to the wall, basically. Whatever it did, it ended up over there. Right. And so this is one of the things that I definitely need to do some more looking into, but I want to talk about it anyway, right now, because I'm just going through everything and I'm trying to catalog where my head's at and what my ideas are, and get an idea of things I might need to look into more. Because basically what I'm trying to say here is, we get a wave pattern when we don't observe it. But as soon as we start, observing it, the wave pattern, quote unquote, collapses, right? And so we say, oh, we make reality, because we're looking at it, right? And then they say, no, that's not the case. It's because we interact with it, the particle, and that has now affected it. And it says, okay, so basically what you're saying then is that once it's hit by that light, its most efficient route is always going to be just perfectly straight. The probability is reduced that much. Maybe it is, right? But a part of me thinks, if you tell your friend, right, run around randomly in this room, I'm going to turn the light on randomly, right? And wherever you are, I'm going to record. Or so you do that, right? And you get like these random results. I really should have done this the other way around. But imagine like you say like, okay, I'm not going to look, but I'm going to, every like 5 seconds, right? I want you to run around randomly, and every 5 seconds say, here I am, right? As you're running around. And then I will track where you are positioned in the room based off of where you say you are. Then you turn the light on every 5 seconds instead. Just because you're now looking at it doesn't mean he's going, like, your friend's running around is going to be less random. They're not always going to be in the same spot every time you turn on the light, just because you're turning on the light now. And maybe this is not a one-to-one comparison, but if we believe that light is quantum, then the wave pattern shouldn't just collapse completely. We should still see more than 2 slits, is what I think I'm trying to say here. Even if the most efficient path becomes basically just straight, I think we should still see within those 2 slits a wave pattern form. There should be still a wave pattern within the slits. And I don't know, like I said, I haven't done a lot of research on this. I don't know if that's the case or not, but if we end up with basically, say we have 2 slits and we have 2 perfect straight lines, basically, and there's no wave pattern within those 2 slits, then I don't know. I think that's weird, right? Because if that's the case, then things aren't quantum. Like they wouldn't be. Like once you shoot it with a light, that means it's like its state is set, right? Once you know its state is locked, and that doesn't sound right at all. So that's why I just have some kind of beef with it. But like I said, I haven't really looked into this a lot. So maybe I'm wrong about how this stuff happens. I would also I don't know what experiments have been done, but like if they do I would love to do this experiment myself, but I don't have a single particle shooting gun to do that. And it would need to be single particles for me to test what I want to test. I've seen people do it with like a laser, and that's not really going to help with the experiments I want to run. So anyway, I think I think that one thing I can say here is, because I do talk about this, is there's no interference pattern. There's just a probability of where they go, a higher and lower probability, because when you're shooting one particle, it can't interfere with nothing, right? It's based purely on the probability, and some things are just more likely than others. And so that's how we end up with a wave, but things can still land in those gaps. It's just very unlikely that they would. And so maybe when we hit it with light, we're not necessarily like, we're collapsing the wave, right? And so it is still a wave in this slit, but maybe it's not that it, like, we just can't see that it's a wave in the slit because the waves are so packed together, right? And some things are landing, like there's a higher probability they'll land in the gaps when the amount of area is limited. So maybe that's what's going on there. Now that I'm like thinking about it, that's probably what's going on, is that the wave function doesn't collapse down to two slits. It just refines. Cause I feel like collapse is a strong word. It condenses, I think, is a better term. The wave function condenses in the slit experiment when you're measuring like when you interact with the particles. If that's what's going on, that would be my explanation. Is it's still got a wave function. It's just been condensed because when you shoot the light at the particle to know where it's at, right, you've now given it more energy, and that increase in energy makes it fly more direct and be less affected by other sources, and so it keeps it more unaffected by outside factors. And the wave function is still there, but it's just so tightly packed. Maybe. Yeah, I don't know. I will be looking into this more. But I do want to say this as well, because I do think that this is a good point. This might be more philosophical than anything, though. But I do think at some point, like, physics is, I was really interested in philosophy and stuff, and I kind of like I like watched enough stuff that I was happy with, I guess, my view on the world, and now I'm looking at physics. So anyway, we'll say that the slit experiment doesn't just work with light. Like, it also works with, like I was saying, other particles. It works with electrons and things. And so this is like particles with mass, right? So we've established that basically mass is also quantum. And the reason why we just don't really see that on the larger scales because the probability is insane. And so it's basically not possible. But it is still technically possible. It's not possible, right? So anyway, we go through life as matter, and so which by entropy follows the most probable path, and as such we are experiencing the most probable outcome of every event. So this is pretty much what I'm trying to get at here, is bringing this back into consciousness. Because even if our consciousness and the fact that we're observing it is not what is condensing the wave function, right? And it is purely just measurement. We go through life, and every instant we are making a decision. For every instant you can either do something or not do it. And there are so many things that you could do. Like right now I could get up and jump, or I could sit or I could stay sitting, right? I could fall on the floor, or I could stay sitting, right? And so even if like you're asleep, like you could spontaneously wake up, or you could stay sleeping. And so we live in this constant like two slit experiment world, except we've got like, there's way more than two slits, to be honest. But but basically we are constantly living in this world of two decisions, right? And we are taking, as matter, we're taking the most probable route, right? But we are also taking every single route, but we only observe one. So when we make a decision, we are observing that decision. That is the direction we went. That's where we were. We didn't go left, we went right. We never went left. We would have never gone left. We always went right. But I don't think that's true. I think we went both ways, but we only saw right. So on the large scale, your life is instances of decisions constantly as you're like moving through time, right? You're constantly having to make a decision for, multiple things really. And the probability of certain things happening is low, but it's not zero, right? And so for the most part, things are normal, right? You just go through your average life and things are, how they are, right? But that's just the most probable path. That's the most like probable path that you would take through life. It's the least resistance, I guess. And so it's not that you can't go make $1 million. It's just very unlikely that you do make $1 million because it would take a lot of energy and effort to do that unless it didn't and it was just by pure chance, right? So, everyone could be a millionaire, but not everyone is a millionaire because it's unlikely for that to be the case, right? And so light is quantum, matter is quantum, your life is quantum. Everything you do, I'm a strong opponent of the multiverse or multiple worlds theory or whatever. I think that is true. And I think that we could potentially be kind of shifting, there's quantum tunneling or whatever, where it's like, we're in this reality and then now we're over here, right? I think that we even potentially have we potentially can quantum tunnel in our own way. We don't notice it happening because to us, nothing's changed. But we could potentially be quantum tunneling through different realities as, we need it. That is maybe something I wanted to say in this or not, but, right. So we go through life as matter, which is entropy, which follows the most probable path. As such, we are experiencing the most probable outcome of every event. And so when we observe a particle, when we observe the particle, we fix its probability in our reality. But the change in pattern is only observed by us in our reality. The pattern doesn't change, right? We do. So when we look at the particle, it's not that we're making the particle, the particle's wave function is still there, right? But we only observe the most probable outcomes based off of, observing the particle. It's not that we're making it's not that we're fixing the particle. We're fixing ourselves to that reality when we measure that particle. Because once we measure that particle, we have now decided in a direction to go, like in our reality. And so we choose the path of the most probable outcome, right? And so once we've measured it, the most probable outcome for that particle is now to land right behind it, right? Rather than to go off into oblivion. And so we fix our own realities to that portion of the wave function, but the rest of the wave function is there. We just don't observe it anymore because our reality is now fixed on just those two slits. Reality is reality is not like set in stone. At every instance, it's subject to change because as time goes on, even if you sit still and do nothing, your entire body is still doing its bodily functions that it normally does. But then also all the air around you is, interacting. All the organisms that are around you are still doing stuff. There's like tiny little bacteria and microbes, and there's dust in the air that's probably got like microbes and stuff on it and things along those lines. Like all of those things are still moving. They're still doing stuff, right? So even if you do nothing, all of those things, right, just in this room are happening and changing your reality. But then you got to expand it out to the entire planet. And it's like, even if you sit here and do nothing, right? Someone across the world could do something that will change your reality, right? Maybe someone is making, your next t-shirt right now. And, that is a change in your reality because that t-shirt will eventually make its way to you. And even though you're doing nothing right now, your reality is still being affected. And then you expand it to the entire universe and it's just, your reality is not fixed. And things are constantly changing all around you. And you have no choice but to make choices. Because, even if you choose to choose nothing, that's still a choice. That's still a path. And there's no way to get around that. But we're like particles flying through time. We're just trying to get to that end wall, right? In the most efficient way possible. We're trying to get there. If we were looking at like at the end of everyone's life, you're just looking at like everyone in your family, like at the end of their life, they're just a point on the wall, right? And, everyone ends up in all these different places. Some people make more money. Some people have bigger families. Everyone's life is different, right? But, you look at it and it's like, okay, well, most of our family is, fitting into these waves where it's like, okay, well, they either had kids or they didn't, right? And then like, maybe no one in our family adopted, right? But like maybe one person did, and then they would be like in that like gap there, right? Where there should be nothing there, but if you adopted, technically you would fit kind of in between those two spots because you didn't have your own kids, but you also didn't have no kids, right? So that's kind of what I'm talking about with these like probabilities, and like your life is basically just you flying through time in this crazy world we live in, and you're just experiencing one of the outcomes, but I would argue it's potentially the most probable outcome is what we're observing. But maybe not. Maybe it's just one of the potential probabilities, and that's just the one we're following because why not? I guess I don't know. Maybe we follow them all, and we just keep living the same life over and over again, but different every single time, right? And so, uh, yeah, a single dot, a single dot after being shot at two slits, yes or no. We choose both, but only experience one because we observe it. Yeah. Anyway, I will be looking into that more. I think it's on my list now, but that's what I wanted to say on that. Is the quantum doesn't stop at particles just because it's unlikely that you're going to quantum tunnel your hand through a wall doesn't mean that you don't experience the quantum. Everything is quantum. It always has been. Peace out.